In this talk, I'll be looking a little bit at the V1 rigging and animation systems and the structure of the tools behind it, and at a very broad level, showing how it's all put together, the data that it relies on to build everything out, and just kind of my high-level thought and goals for the toolset as a whole. But first, I'll look at the pillars or goals of the toolset. One of the three main points, I guess, are modularity, being data-driven, and focused on the user experience while using the tools. Starting with the last one, I think user experience is probably one of the most valuable things that's kind of driven the whole modularity and data-driven approach. Because if the users, through my experience working with artists, animators, character artists, everything, if the tool isn't convenient to work into their own personal workflows, it often just gets ignored and either unused or really underutilized. So I want to make sure that the tools support the user just as much as the programming supports the tools. So for modularity, we need it to be very expandable. With a rigging system, I don't want anything to be stuck in really any state. One of the big goals of our toolset is from seeing a flaw in how rigging is handled in other studios, where really once a rig is built, it becomes exponentially harder to go backwards and make changes to the character, the skeleton, or anything else. And I think that kind of limitation on anything in game development is really problematic and is kind of the points in a content pipeline that I want to see eliminated. Like, we should always be able to go back, make adjustments to our skeleton, and bring those forward through a fairly painless process. Whether that's just adding a simple joint or even modifying a hierarchy or moving position of joints, at least early enough into development. Too much of a structural change on the content is always going to have a ripple effect through the animation, since the animation is built off of that content. So there's always going to be some stuff we can't just go in and completely reconstruct, but for the most part, we can make changes. We can use batch processing to update changes through all of our animation files if we need to. But the core of the rigging toolset here is that it supports back and forth exchange between character modeling, rigging, and animation, and never puts a block on that iteration that prevents an animator from being like, oh, I need this functionality, and then going back and looking at like, well, to get through that functionality is going to be a month's worth of work, so we're not going to do it. Another big piece of it is, through my rigging experience, I started seeing simple patterns in how any kind of rig is made that were really underutilized in other rigging systems. So for example, other rigging systems, if they had a Z leg or even a bipedal human leg, would tend to have that be an entire component in and of itself, even though it is just an IK chain through the upper leg and then some FK controls for the foot. And same with the Z leg, it's really just an IK chain through the knee down to that third joint, which is the ankle, but it actually looks more like, I guess, the end of the leg. It's not the point that connects onto the ground. And then an FK structure underneath that supports that IK. So we really just have an IK chain, an FK structure, and the bulk of the work on the tool set is a system of constraining different things together in simple but powerful ways. So a constraint system is actually both a constraining system, it's our space stitching system, which is a way for animators to work with controls in multiple spaces. So if they want to have a hand that reaches out and grabs onto a moving vehicle, we need a way to have that hand be in the character space, so when the character moves, the hand moves, but then move out of character space and be in the space of the vehicle. So now if the character moves, the hand stays on the vehicle. If the vehicle moves, the hand follows the vehicle. So I have one system, it's kind of the third point of modularity, robust connections between simple pieces. The simple pieces being IK and FK, and then a robust system of ways of connecting those IKs and FKs, or different FK controllers to different FK controllers, are really connecting any piece of the rig to anything else in the scene. And for rig building, we use it more specifically as ways of connecting IKs and FKs together. So in the case of a leg, we have a single IK through the leg, we have an FK structure for the foot, and then we have a series of constraints that define the relationship between those two. Instead of that all being one entire thing on its own, we're really just using two simple systems and a way of connecting them together. And then modularity is important because you don't always need everything to be exactly the same way on your character every time you open it up and work with it. If you're making a really simple change, like you just need to change the shoulders, you don't need a full rig in your scene. You don't need all of that weight kind of bogging down your scene. You could just rig the shoulders, make your adjustments, bake it down, and you're good to go. Data-driven is it's more of a programmatic design rather than user-focused, but it's what really enables everything else to be user-focused. Having data pulled out away from the system itself, we can look at that data in much simpler ways than if it's all combined in the code. So we have data that really drives what the code does rather than code that drives what code does. So again, going back to other systems I've seen, like normally if you wanted to build a rig, there would be a master rig script, which is a large just Python file generally that runs through all the steps on how to build the rig. But that's not approachable to anyone but someone who knows Python. That's not approachable to an artist or an animator who may want to build out their own custom rig for a character and save that data off and be able to reapply that rig whenever they want. So we have two main data structures under our characters. One of them is a character settings file, which is a description of the full skeleton of the character, its whole relationship within that skeleton, so the whole hierarchy of the skeleton. And then all of the pieces of data that have been attached to that skeleton, like whether a joint should export or if it's set up as a rigging region, so we can quickly say, like, this is my left arm, and we can generically use the term left arm for any character no matter what their joint structure, what their rig. And then there's the rigging component, the rigging data, which reads in that settings data, or reads from the settings data to figure out where it should apply. So we say apply an FK to the left arm, or apply an IK to the right arm. That's all we really have to define in the rigging setup, as well as the robust connections that change the relationships within the rig. But all of that works, again, generically based off of the data from the characters. So it doesn't matter if we have a 4-armed alien or a 2-armed normal human. If they both have a thing called left arm, the rigging file will just build whatever it needs to on that left arm or whatever regions it finds in the skeleton. It's not beholden to a very specific setup. It's really just data that's, again, working off of the character data. So it's kind of, I guess, 2 levels of data on that. And then the whole tool set is kind of built around working with and manipulating those data structures. So when you make changes to the data of the character in the Maya scene, we save that off to a settings JSON file. All of that is I guess the details of how they get saved, what's getting saved, what it's doing, and how it loads is all hidden away from users. So all they really have to do is change data that they want. Say there's a new region on the character, we add another arm. So we mark it up for rigging. Then they save that data off. It gets saved off to file, and it's ready to be used or reapplied as needed. So all the tools are kind of built around that modification of data, whether it's saving it directly to file or changing the data in the scene itself, which could be saved to file or could not. There's a lot of times where maybe we have this one-off shot where we just need an extra piece of rigging or an extra connection point on the character just for the shot. We don't really need that saved off for every single animation. We can just put it in that one scene and call it good. And from the animator's perspective, we also use the idea that data is the start and end point of our work. So in this case, an FBX file is our start and end point. The whole system is able to be worked off of without having a single Maya file saved in any form. And you could just load an FBX file, run your rigging, or change your animation, re-export it back out to the FBX file. And this gives us a lot of flexibility in never having that rig as a lockdown piece of the pipeline. The rig is a way of manipulating data that is going to go into the pipeline, but it's never a blocking point, or should never be a blocking point to how character animation flows from the artists into the game engine. Then user focus, I've already touched on a little bit. It's really focused on providing ways for the artists or animators to interact with and modify the data through really simple means, whether it's just entering a text field or telling it to load a rig, apply different rigging, and save it back out. It should be usable by animators without any real technical background. That's really the overall goal. I think we've been pretty successful with it. In disintegration, Matt Lefferts pretty much handled the entire vehicle pipeline without really any real support from me. I was there to support for any kind of problems that came up, but not for any actual rig building. It was really just kind of advice on how I would approach building a rig, but he was able to use the tools fully without my intervention or without me being a part of the pipeline. Which is a huge bonus because he's going to know how he wants his characters set up more than I am as a technical artist. All I would introduce to that pipeline is him telling me what he wants, me building it as best as I can imagine what he wants, giving it to him, and then him telling me that, oh yeah, these parts are good, these parts are not quite what I wanted. If we can remove that back and forth out and just have the animator go directly to the tool set and say, okay, this is how I want my rig to look, this is how I want it to behave, hit save, and move on. So the whole underlying code is built off of a C# framework with Python handling DCC interaction. A big reason why I went with this route is there's a lot of power in different areas of programming that C# and Python provide. C# is really good at building UI in a not only like a modular way, but a very clean way of working between data and UI. So when I was talking about the toolset being data-driven, XML or XAML, using what's called an MVVM structure, which is model view model, allows us to, again, work off of a single set of data. So the UI can still work off of all the data that I'm using within the scene itself that's managing all my systems within the rig. And present that in a UI that can be changed however we want. There's a nice separation between that data and the UI. So model view view model means the model is your data, the view is your UI. And then the view model is an intermediary that reads your data and presents it to the UI. So we have a nice midpoint that the UIs can really easily change without having to change the underlying data structures. And this has been, again, really valuable. An iteration of just our rigging UI itself. I think the animators would be able to tell you themselves that usually if there's a UI-related feature that they want changed, it could be as little as like minutes to work it out, or I think the longest ones is maybe a day to make changes and get that turned around. So that really gives us a lot of power in changing the user experience of the toolset to however they need, and not having to worry about what the data structure is. We have that intermediary that can handle that exchange from our data to our UI. XAML is also a very full-featured toolset for Windows. It has pretty much every UI functionality you could really want for any kind of a tool UI. I'm already built in, so I don't have to go through and write a bunch of my own custom tools or anything. I would say probably 95, maybe more % of all of our UI modules are just built-in XAML features. And I've had very little modification to make everything work for us. This is also part of the whole model view view model structure, where I can customize that data in my view model to be presented how I want it to in the UI. And then data bindings in XAML make working with the data and the UI really seamless. And something like PyQt, which is what I've used in other studios. Any kind of link between your data and your UI has to be hard or you have to write the management. So if I wanted to change my data and have that reflected in the UI, I'd be essentially storing two pieces of data, one that's my data, one that's the UI data. And I would need to automatically update my UI whenever my actual data changes, or if I change something in my UI, I'd have to manually write the code that reads that change from the UI and applies it back to the data. Data bindings manage that pipeline just on their own. I don't have to write anything to create those link connections, and I can use a data binding in multiple different ways across my UI as well. So if I have a list of objects that I want to display in two places in my UI, but I want to display different information about those objects in different places, they both look at, the data bindings both look at a single source of objects, like a single list of things, and then reads them and applies UI based on how I write it to display whatever I want from each of those pieces. Makes it really easy to change a list of things, list however things I want, or display the UI really however the data needs it to be displayed, without me having to write accessing code for every little piece. C# being a Microsoft developed language also has a ton of Windows operating system functionality. It's really well integrated into Windows, as you would hope. So I rely on C# for really all of my operating system interactions, and I just use C#'s base modules for that, so I don't have to write any of those interactions myself as well. And then finally, events are a really powerful tool in C#, and they're also really powerful for modularity. All an event really is something in the code that can store different operations. So if I have a button pressed in my UI, it will fire an event and then the code. So moving over to Python, the Python can tell the UI what it should do when that button is pressed. It can load its own functionality into that event as ever it needs. This gets really nice for using UIs that are cross-program. So if we have a UI that needs to be used in Unreal and 3ds Max or Unreal and Maya, and we want them to be the same UI, but to run the specific functionality of Unreal or Max or Maya, the Python code in Max, Maya, Unreal can load its own functionality into that button press. And we know that we're getting that cross connection. So I never have to write two UIs that are doing more or less the same thing. I can write one UI that does the same thing, and whoever is using it can kind of determine what its functionality is using events. One of the main drawbacks of C# is that it's a compiled language, which means it's not editable at runtime. So if I'm making a change in Maya, I have to close Maya, recompile my code, reopen Maya to see any changes. That's a pretty slow iteration loop. There are tools for UI specifically where you can inspect all the data of your UI, make your changes so I can get all my sizing and everything correct, all my values correct in one load, then move that over to my code. So I don't have to go back and forth a whole lot when I'm building UI. But if I were building DCC interactions, having to reload Maya every time I make a change to see its result would become very slow. Also, even bigger point is most programs don't have C# support, so I can't actually use Maya or C# in Maya to call Maya functionality. There's just no way of doing it. So that's where Python comes in. Python is interactive or has DCC interaction for nearly every program. For those who may not know, DCC's term is digital content creation. It's kind of the broad term used for any content creation package, so Max, Maya, Photoshop, whatever else. It's really just a program that works with or creates digital content. And nearly every mainstream DCC program has Python integration built into it, so you can use Python to call the majority of the functionality of the program. So that's obviously a huge plus. We can't really do a lot with our tool sets if we can't tell the program to do what we want it to do. It has essentially instant compilation. It's not quite the right term for this, but it's the easiest way of describing it right now. What it means is I don't have to close a program, rebuild my code, and reopen the program. I can tell my code to recompile at runtime without having anything modified. So while I'm working on my code, I can just tell my code to reload, and it reloads up with my new changes. I can see how my changes interact with the program. If something is broken, I can make another change, reload it, and I can just keep on doing that iteration loop without ever closing Maya down. And the reason why both of these work so well together is the .NET integration in Python is really nearly seamless. The .NET integration really gives Python the ability to work with C# as if it's C#. So it reads really any C# object. It does all of your data conversion for you. So if I'm using a Python integer, it converts it over to a C# integer for me. If I'm using a Python list, it converts it over to a C# array or a C# list. Reads them back the exact same way. So I can interact with all my C# stuff natively in Python and have access to all of it. So I can load my Python methods onto my C# events. I can call any C# code I want or access any C# objects that I want directly from Python. And that really means that we can use Python as our launching point to build create our C# UIs, and then the Python can load all of its functionality onto those UI events, and it's really just good to go from there. And working between the two, having a single IDE with Visual Studio It has full Python and C# integration. Also means that I have a kind of a one-shop stop for all my code. I don't have to bounce between different IDEs for each language. I really just can stick in one environment, work on all my code at once, and just have it all work really well. So I have a little video here that's going to go over how the character data is applied in a Maya file example. We're going to look at the settings file. First, we look at how quick it is to get a character loaded and built, essentially, or ready for animation. And then I'm going to take a little deeper dive to show that our Maya files, even though we do use them and we save them off, are more of just a convenience. Really what matters is the data settings file and the data rigging file. So we have basic running animation here. I'm going to open up the rigging tool and then just load a rigging profile. This Maya file already has all of our settings file loaded into it. It's kind of all that save state of data that I was talking about. So this rigging file is just looking at those pieces of the character, that arm, that spine, the head, and applying the rigging it finds to all the correct pieces. And within a few seconds, I think our rig build time on something like this is around 10 seconds. All the animation is transferred, or all the rigging is built, and then all the animation from the skeleton is transferred onto all the rigging controls. And you're ready to just start animating from there. But we don't need to have that Maya file structure at all. All the information is saved off in our settings file. So here I'm going to create a skeleton joint as my starting point, just so I have a way of characterizing, like setting up an object in the scene as a false character at this point, really. It really just gives me a launching point for the UI to start working. So I have a single joint, that is my root joint. I tell it to characterize. This is just setting up that base level of data. And then we have this idea of a rig path, which is really just telling us what character is this. I'll go and choose the armature. All this really does is populate my settings and rigging menus in the UI, so I can quickly find it. So if I load a settings file, it actually builds the entire skeleton and all of the skeleton data for you. And this gives us kind of our launching point of this is really our character. The model is really just a shell on top of this character. From there, I can grab off screen. I grabbed an FBX file for the jog, drag it into this scene, and Maya automatically updates the joints with the same name. So we quickly build the skeleton with the settings file, load in an FBX animation onto it, and then we have this swap character tool, which will go and find whatever model of any character that uses the same skeleton and pull it onto the character, or pull it onto the skeleton. So you can see within a minute from nothing, I'm able to build all the data that is the character, which is really the skeleton, and all the skeleton information that is what drives the whole rigging system. Apply animation to that skeleton, pull in the character that works with that skeleton, then apply my rigging, and you'd be ready to start animating from there. We use Maya files. This is kind of a convenience. So instead of having to go through all of these steps every time an animator wants to work on something, they can open up our base rig file to start with, which is the character skeleton with all the properties assigned and the mesh already applied, and just start from there rather than having to go through this process every time. Then we also save animation files with the character set up, so again, they don't have to run through and apply rig, and they can kind of have a save state for that character animation. But none of it's actually necessary as far as the rigging system goes. Those are really just conveniences for quicker animation work. And in this video, we're going to take a look at the deeper systems that the character settings file created, and how we kind of make use of the power of that to let the tools really interact with everything in the scene. Here we're going to look at the underlying data structures that are built off of our character data that serves as kind of a save state of information in the scene, either based on what was built out or what the users have decided to do with the rigging data once it's in a scene. So from the top level of any character is probably the easiest access point to visually see it in Maya's node editor. The first input connection from that top character group is going to be our character network. All of these objects are essentially save states of code objects that I have. Call them a meta type. So this is in the network core module. It's a character core class. And let's actually go to one with a bunch more information so you can see a little more clearly what it's doing. So this is a meta properties module, and then the control property class. And as you can see here, it's kind of a save state of the information of this property object from my programmatic class. So we have the index of the object, or the control in this case. Oops. So we have the index of it, that's just kind of 1 or 0, 1, 2 in this case. We have a 0 translate and a 0 rotate, so that the control object can save essentially what its 0 poses. For the majority of controls, this is always going to be 0, 0, 0, 0, 0, 0. But when an overdrive gets applied, it's applied in a new space that's different from its actual character space, which is 0, 0, 0. So an overdrivers generally make more use of these 0 translate and 0 rotate values. We have whether or not it's locked, and then what type of control it is, which is just a quick way of looking up information if we have an object with multiple types of controls. So IK has an IK handle and a pull vector. They're two distinctly different hierarchies of objects, so they have different control types. So every one of my programmatic classes has its own data structure, and the code behind it automatically essentially builds and sets the attributes on my nodes for me. So I don't actually have like a static list of attributes that make up a control property necessarily. I have the default list of attributes, but at any point you could set or get any name of any value you want, and the system will create that object or create that attribute and give you if it doesn't exist, give you a default value. If it does exist, find it and return the value that's currently saved on it. So they're more of a generic framework for storing any amount of data than they are a specific structure as far as the Maya side goes. As you can see from the character side here, this is all a tree structure. Here we go. So we start with the network core. Every object within the hierarchy has essentially a record of what it depends on to be created. So if I didn't have a network core yet and I wanted to build the export core would know that it needs a network core to exist, find that network core in the scene, or if one does not exist in the scene, it will create its own as a starting point. And having this really simple structure underneath a lot of complexity that is a rig makes it really lightweight for me to search. So all I have to do is a quick breadth first search over this tree, And I can find really any information about the whole character skeleton, each individual rigging piece, really anything that I want. So I'm looking at the character, I can say, find me all of your component core networks. It will search down the tree until it finds each component core network. It's pretty fast since it's a couple node search. And then I can look through all those components and find, say, my right arm, or every arm, or every right side control, or whatever kind of search I want to do over to find information quick in the scene. I use this a lot for batching. I can also ask my code to just give me all the character cores in my scene, which would list all the characters that are in the scene. I don't have to open it up and do any kind of verification through the hierarchy or anything like that. I just ask it for all of these character core objects. It finds the network core, does it search off the network core, finds all these cores, and so on. So it's a really quick search to find whatever I want for automation, but also just a quick check of what's existing and what's a part of everything. So we have a component here, which gets a little bit more complex. And the component itself has all the rigging joints, all of the control joints, all of the skeleton joints. So if I want all the control joints from a rig, piece of a rig, all I have to do is find the control joints network object, and then all of its inputs, or I get outputs. There we go. Are my 3 controls. Same with the skeleton underneath it. The character core has track of every skeletal joint in it, as well as both the root joint and the overall group. So this all just makes it so I never have to search the scene hierarchy for anything. All I'm really doing is searching my own data network structure to find any piece of a character and be able to quickly work off of it through code. And I also use these nodes as a more recent addition. So I have all these animation curves that I've actually plugged into this network node that are doing nothing. This is actually a save state of the animation that was on this arm prior to rigging. So at any point, if a character artist was working on it, trying out some experimental thing with their animation, they decide they don't like it, they don't have to reload their file or lose any work from that. They can actually just tell the rigging system to revert to all the previously rigged animation, and it will reconnect all of the animation curves back up to the correct joints. On top of being a strict tree hierarchy, I also have properties in the system. We have this control property here. This is the one that we were looking at before. This doesn't have any greater connection into the rest of the network tree. This is just a property for this object that defines how that object, or some saved data that I need for that object. In this case, it's zeros, whether it's locked or not. In the case of the exporter, wrong way. So in the case of the exporter, we actually have all of our export definitions, and then the definition itself. So this is the animation. This is the character of the animation. And then I have a property that's on either of them that the exporter will essentially find all properties on both the definition and the asset. So remove root animation property in this case. Construct the code object or the class underneath it, and then run a basic method on that applies its functionality to the skeleton that's being exported. So in this case, it will find the root joint of the skeleton and remove all animation curves from it. But we have a bunch of other properties as well that perform different actions on the export process. All of this kind of adds into the modularity of the toolset as a whole. And that is about everything that is the underlying, the broad look of the underlying data structures behind all of our character rigging. You have the basic tree that lets me quickly search back and forth throughout it and find whatever part of the character, piece of the character I want. We also have property nodes that we can tag really any amount of information onto any character, and those properties will save out. And we can always restore them and then access the code functionality off of that restoration whenever we need. Overall, it makes it really powerful, really fast to find everything, and makes batching any of our scenes really great. Because I don't have to follow some convention of what is our character setup in a hierarchy, especially in a cinematic scene that may have hundreds or maybe more objects in it for the environment as well as the characters. I'm not stuck sorting through everything in a scene in order to find my characters. I'm just looking at my network structure underneath it, finding all my characters, and then finding whatever piece of the character I need. So going forward with the tool set, there's always going to be a lot more work to do just getting base functionality done. But one of the things that I've talked with Mike and Marcus is kind of the future that I want to see with it, which is going open source with the rigging and animation pipeline we've developed here. This kind of gives us kind of multiple benefits. One, I really want to enable developers to do the best work that they can at any kind of level. Ideally, well, really, any kind of independent studio out there doesn't have access to someone who can build out this kind of a tool set and give their animators the ability to do their best work. And I'd really like to see something out there that, again, enables animators to be able to do their best work no matter where they're working. So open sourcing the toolset gives small studios or individuals industry standard, not even industry standard, but I'd say top of the class of industry rigging toolset to build out their functionality in ways that they don't need a technical artist to handhold everything for them and build everything for them. I'd expect an animator with at least a light technical background to be able to do a full install of the toolset, get everything up and running, and get it all ready to go for their own work. But it also enables the toolset to become better faster. As is, we have 3 animators working with the toolset, and while the feedback that the whole animation team always gives me is really great, it's always going to be constrained to the type of projects that we work on and the type of assets that we're building. And even just the environment that we're working on, that there may be, not necessarily issues, but there may be features that toolset could use that would make it better as a whole that we won't ever think of because we're not hitting up against hard problems that require a tools change. A smaller independent studio might hit up against, and by open sourcing it, I can enroll other technical artists that I've worked with and trust to change our code, and have them be kind of co-developers of the toolset. And then we can start expanding the whole use of the toolset between or beyond just our studio. The features and functionality of the set as a whole will grow with every new studio who's really adopting it, or even individual if they're a technically savvy individual. And so that's kind of a way for us to really push development and really push feature set that is applicable to more than just us, or even get functionality from someone else. So if other studios start using our toolset and start expanding on it, they may build features that, well, we don't need right now. If in a future project we decided we want to do something, that work might already be done for us. So that's kind of the drive to open source this toolset, is to give back to the community that, or the development community that really makes everything we do possible, and to hopefully build a, I guess, community around the toolset itself where more than our input is going into it, and the tools will be better for it, as well as having more than one developer developing the toolset will create functionality that we could use in the future that we don't have to build ourselves. So where we're at right now is our toolset is hosted privately for the moment on GitHub. The rigging and animation tools are entirely broken out from the rest of our studio-specific tools. So we're not giving away anything that is specific to how our studio works or how we have things set up. It's more of just the, like, if you have an FBX skeleton and you want to work with animation on it and rig it up, here's what you need to do it. I've already rolled out access to that private GitHub to some industry technical artist friends for kind of their small scale evaluation, to kind of give me a gut check of how the install process works and their just kind of first thoughts of when they go through a character setup. How does it feel and what do they think about it? After that, I'll be working with some targeted studios on adopting the toolset for their studio work. I already have at least 2, possibly 3 studios that are interested in checking it out and seeing if it's something that they can adopt. The first wave of that is going to be largely making sure that all of the functionality that is specific to V1 is pulled out and made customizable for another studio to come in and use the toolset in their own pipeline. Once I'm pretty confident with those first 2 evaluations of technical artists taking a look at it, and then working with a couple of studios to see how it feels for them to work with, what kind of problems they may hit with it, something that may limit them from wanting to use it, getting those addressed. Then we'll move everything to a publicly hosted GitHub, and at that point it will be really freely available to anyone who comes and finds it. I plan on first reaching out to local schools and asking them if they would be interested in kind of adopting the toolset for their students. And then from there, you can also start broadly broadcasting out to animation groups and other industry friends who may, like we think, may want to use a toolset like this, and see what kind of adoption it gets from there. A lot of it is really going to be just kind of rolling with how people take to it and what people think of it as we go. And that is all I've got. That is our toolset and the kind of high level of how it works, and a little bit of look at where I want to take it and where we plan on taking it in the future.